Okay, in the mechanics course, we considered an object launched from ground at some speed v naught, and we plotted, well, we solved the equations, and we noticed that if y is the height and t is the time, then the object travels upwards in time and slows down, reaches a maximum point, and comes back down with a speed which is equal to the speed with which it was launched. Of course, the direction is different. And then we changed the direction of time, and we had time, the direction of time going from the positive to the negative, meaning that way. And so at t equals 0, we launched the object up at speed v naught, but now we had time, the direction of time in the negative direction, and we found that we got the exact same description, that the object goes up, reaches a maximum height, comes back down, and hits the ground with the same speed. And this time, the time associated with hitting the ground, here is positive, and here is just the negative version of that same value that we got. And the point being that we were trying to explore whether or not we get nonsense if we reverse the direction of time in the equations. And we found that we got the exact same description. In other words, the laws themselves, in this case, the kinematic equations, don't care about the difference in the direction of time that way or that way. And we could do the same thing now for electromagnetism, but it's easier to avoid solving the equations like we did there. And what we want to do now is to think about this process, and essentially imagine making a movie of this process and then flipping that movie around, reversing that movie, playing it backwards. That would just flip this to that value, and then the object would go up, slow down, and come down and reach the ground that way. But that's the exact same thing. So it's going to be easier for us to think about making a movie and playing it in reverse, and then seeing whether or not what we get doesn't make sense with the physical laws. So let's imagine that we have a uniform magnetic field. So here is our magnetic field into the page. And let's have a charged particle of, say, charge Q sitting at rest. All right, so the particle is at rest right there, and there's an electric field pointing that way that will speed the particle up because we have an electric force Fe, which is Q times E. And so the force will speed the object up that way. And so its speed increases while it's in the electric field. And then it ends up coming into the magnetic field, let's say with a speed V naught. And of course, the magnetic field will make it turn, right? Because we have a magnetic force, which is FB equals Q V cross B. So this force will be V cross B, which is into the page. And so the thumb tells us that the force will make it turn this way. And so the object will go in a circle like this. It won't change the magnitude of the velocity, of course, because magnetic forces do zero work. So we'll get something like that. Now let's imagine that we make a movie of this process, right? So instead of solving the equations for the different direction of time, let's make a movie of this and play it backwards. Well, what do we get? Well, we're going to end up flipping the direction of the velocity. So we'll get the particle behaving this way, coming over here like this, and then entering the electric field like that, and then having to slow down. So this arrow is a little bit smaller than this one, exactly like this one is a little bit smaller than this one, and eventually the arrow goes to zero and the particle comes to rest in the electric field. So we have a magnetic field here, and we have a magnetic field here, and let's say that we insist on the magnetic field being into the page. Let's see if we get nonsense. Let's see if we can reconcile this motion with the basic laws. So if the particle travels this way, the force here must be this way. So we have V, right? So we still have V cross B, but B is still in, and so that means the force would be this way unless we take Q and turn it into minus Q. So there is the possibility of this kind of motion. It can be made physically reasonable if the charge is instead negative. So we have a negatively charged particle in a magnetic field that's in that direction, and then that negatively charged particle comes here and experiences an electric force. But the problem now is that the electric field has to be that way in order to slow down the particle. So that's still physically reasonable. There's nothing strange about having a negatively charged particle and an electric field that's pointing this way that slows the particle down. So that looks reasonable. We could instead have a magnetic field B that instead of flipping the value of the charge, we flip the value of the magnetic field. So we have a magnetic field that's everywhere out of the page. In that case, we can still get this kind of motion. And then in the electric field, the particle will slow down, but we can still have the original direction for the electric field that would act to slow the particle down. It would be the same situation that we had here. The particle, but the positively charged particle gets sped up, and now when we launch the positively charged particle in the electric field that's pointing that way, it will slow it down. It will come to a stop like that. And so that's another reasonable configuration of electric and magnetic fields and charge. So we have the particle is positively charged. All we have is a magnetic field that's flipped with respect to these configurations. So the point is that we don't notice anything funny about flipping, of making a movie of a process that obeys this law and then playing it backwards. So the time reversed picture, right, although it's not exactly the same as it was, for example, in the simple kinematic equation for an object launched in the vertical direction with gravity, the picture is still reasonable. So it's still physically reasonable, right? So this, at the fundamental level, the laws don't forbid this time reversed picture, whereas at the macroscopic level, we notice something very strange about changing the direction of time, making a movie of a reverse process, we can imagine many very strange processes that we don't observe. These time reverse processes we observe.